In this video, you're going to learn how you can use Lychee Slicer to use the resin printers that we have at school. First thing to do is, like with Cura, you need to set up the printers that we have in school. It's very easy to do. In the description to this video, there's a link, and that link will take you to a folder which has this little document in here, so you need to right-click on that and go download. That will then download the file to your computer. What you do next is you click on this 3D printer icon here, and you go import, and then import 3D printer profile from Lychee Slicer exported file. So we select the file, and then you've just got to find where that file is in your downloads. And then you go open, and then you might have to restart Lychee again, but then that should bring up all of the 3D printers we have with all of the associated resins that we have in school as well. Now this is really useful, and it's very intuitive to use because you can literally decide which printer that you need to use for which kind of part. So the Creality one is quite small. It's good for like small parts, and if you're just doing like little sort of test prints of out of resin and stuff, then this one's great. The Photon Mono X 6K is the next size up. That one's pretty big, and then the biggest one is the 006. Personally, I find that the Anycubic is a very good one for using with larger prints and things that need to be made from stronger resins or more specialist resins. And then the little one here is great for doing sort of small, very detailed items. So once you've got your printer set up, the next thing to do is to import a file. So I'm going to add a file. Now you'll notice actually on my 3D printer profile, I've got the Halot 1 is selected, so the little one selected at the moment. So what I'm going to do is add a file next. And here's a sample part from a student's example CAD model. So I'm going to bring that in. Okay, so as you can see, this one is pretty large. In fact, it's too large for the print bed. And we can see that because we've got the areas in red here. Now, this is a good example. If you're printing something this big and you're sure that the dimensions are correct, then we'd have to switch printers. So this is where I'd go to printer, and I'd probably go to the Mono X 6K. Now, this is where I'd also choose which resin I want to use as well. So with the Anycubic printer, it's good to use the Anycubic resins. And the standard ones that we use are just these two here, the Rapid Basic, standard black or white. So I mean, white's good because it's easier to paint afterwards. So I'm just going to select whites. Yep, and then that's all good. And what's so good about this is basically this software does all the work for you because you select the printer, you select the resin, and and then we kind of get it ready to go after that. So the next thing is you can see here that the print bed there, or the resin vat, that fits nicely in there. But with resin printing, it's a bit more technical in terms of how the part is positioned for printing and how supports are positioned and all that kind of thing. Now, again, luckily, Lychee will do all this for us. This little magic button here, you click on that, we make sure all these are turned on. What this does is it works out the best orientation for the model, works out the number of supports and optimizes them, and also sorts out the raft as well that will be needed. You can leave it on medium, and then you just go, literally, I'm feeling lucky. And then what will happen here is the software will just sort of figure out the best way to print this and the best positioning, and then it'll work out how many supports are needed. And it will even tell you the volume of resin that it's going to use as well. Okay, so this is nearly done. And it's just adding the supports, and then the raft is the sort of the bed that's built on the build platform. That's kind of what holds the print onto the build platform. So you can see it's a lot more mathematical the way it does this than Cura. Cura is a much more straightforward process in terms of the computer power that's needed. Now this one we can see doesn't quite fit on here. It's just going over the red there. So we're going to need to move this so that it can actually fit onto the bed. So I'm just going to move this, get the yellow arrow and just move that a fraction over just so it fits inside, and that just fits there. Okay, now you can see with this, the difference in, you can actually see the difference in the style of the support structure. The support structures are really very different indeed. I mean, this is more what's called like a tree of supports. And this is I mean, this one looks okay, I think. To be honest, with resin printing, most of the time it's just trial and error. You print it and you hope for the best. I mean, to be honest, often with supports, it's better to have more than not enough, because otherwise, when there's not enough, you get areas that warp a little bit and they don't come out properly. So if I went to prepare, we can then you can even add on custom support. So if you wanted to add some more manually, you can literally just click your mouse and it will add them on. But if you want to go auto, you can slide up the density if you want to high, and we can do that again. We can just go generates supports, and then we can do that again. I've found from experience with 3D printing on resin printers that, when there's not enough support, that's when you get problems like the print will warp and it will bend and it won't quite come out the shape that you want it to be. The whole point of resin printing is you get an accuracy that far exceeds any FDM printing process that you can have. The fact is that with this Anycubic printer, it has a 6K screen, so the resolution that does the printing is actually 6K. So it's got an incredibly high resolution on the printing. So that alone is something that's worth bearing in mind. So you want to get this right first time, really. So we try to minimize the amount of errors that we have with these. And also, I mean, it's just because it takes a little bit longer and the resins are a bit more expensive. So we'd only really use this when you know that the final print is good to go. All right, so that's saying it's done all the braces now and all the prints. There we go. So you can see we've got all the, that's a lot of support structure there now, but that's fine. That's what we want. And we're going to have to move the whole thing across as well, just so it can fit onto the build plate. Ooh, that's not quite fitting there. So we might need to do a rotate. So let's see if we can just get this to fit. If we go arrange, and actually we'll go move, and then we'll just move that across there. And we can just get it in there. There we go. Okay. Then once you've done that and you've got the supports on, you can click on the file and go export. And you literally just go, you leave everything as it is. You just check that the printer is correct and you've got the right resin. And you just go export slices. And what it will do now is it will slice the model. There is an advert that comes up, which is kind of annoying, but that's the price we pay for free software. Once you've done the slicing process, what's quite helpful is to get this slider here, and you can slide through the model. You can just see how it's going to print. So it's going to obviously start at the bottom. It'll do the raft first, which is that base there. It'll print up and up and up, and you can see how the LCD screen will expose each layer to the UV resin. You can see gradually it starts then building the part there. So this is a good way of also checking if there's any major overhangs or any part of the design that's not going to be supported. So you can see just go slice by slice all the way through the model. You can see what's support and what's actual product there. And and then it will show then the final layer at the top. So once you've done that and you're all happy, you can just export it and send it off to the 3D printer.